In this video, we're going to talk about three-variable system of equations. This piggybacks on two-variable system of equations. There are three types of answers that we are going to get. So three types of answers. The first type is known as one solution. And when it is one solution, that means that it is going to be in the form of x, y, and z. Right? So instead of an ordered pair, this is known as a triple, an ordered triple. So ordered triple. Most of our questions will fall into the one solution. And then we sometimes have a no solution, which means that we are not going to get an x, y, and z. This is also known as an inconsistent. Make sure I spell that correctly. Erase that. So inconsistent. Okay, system. And then so for our answer, we can either write inconsistent system or we can say no solution. I'm in the camp of no solution. And then finally, there are many solutions. And what makes this a little bit harder for many solutions is that we actually want to find out how to actually get the order triple. So on this problem, what we're going to do is we're actually going to have expressions that will help us find the ordered triple. So we're going to find expressions to help figure out all the ordered triples. Okay, so those are the three types of answers. So let's first do a one solution type of problem. So here is our problem. So we have, notice that there are three variables, so x, y, and z. Notice that there are three equations. So for every variable that we have to add in another equation. So if we had four variables, we would need four equations. Okay, so the first thing that we want to do, just like we would do for solving systems of two variables, we want to eliminate a variable, right? So eliminate a variable. So you get to decide what variable do you want to eliminate, right? So when I look at this problem, it looks like the x's are probably going to be easier for me to eliminate. So that's what I'm going to eliminate. And I'm going to call this 1, 2, and 3. So I know which equations I'm talking about, right, so to speak. So I'm going to go ahead and I'm going to eliminate my x's. So that means I'm going to deal with equation 1 and equation 2. So equation 1, so x minus 2y plus 3z is equal to 9. Negative x plus 3y plus z is equal to negative 2. So again, how do you want to eliminate is up to you. Do you want to do substitution or elimination? I'm going to go ahead and eliminate. So if I add these equations together, the x's are going to cancel out. So negative 2 plus 3 will leave me with y, and then 3 plus 1 gives me 4z. 9 plus negative 2 gives me 7. Brand new equation, never seen it before. So I'm going to call it equation number 4. So now I want to do this process one more time, but I have to use equation number 3 because I haven't used it yet. So no matter what, I have to use equation number 3. So 2x minus 5y plus 5z is equal to 17. Now it is my choice to figure out which other equation I want to use again. I personally like the second equation, so I'm going to use the second equation. Now, for the second equation, so as I plug this in right here, if I add these equations up right away, unfortunately my x's aren't going to cancel out. So what I need to do is I need to manipulate this equation. So I'm going to go ahead and I'm going to multiply both sides by 2. Multiply that side by 2, multiply that side by 2. So as I do that, this becomes 2x minus 5y plus 5z is equal to 17. And this will become a negative 2x plus 6y plus 2z is equal to -4. Now I can add these equations up. Let me draw that line a little bit better. 1 second. Perfect. All right, so those will cancel off. -5 plus 6 just leaves us with a y, and this will leave us with 7z, and 17 minus 4 is 13. This is a brand new equation. We've never seen it before, and now it's equation number 5. The biggest thing to remember is that equation 4 and equation 5 should have the same variables, right? So again, if we're kind of thinking about that, make a little note. 4 and 5 should have same variables, because now we have to do this one more time. So I'm gonna look at 4. I'm gonna look at 5. I want to eliminate. It looks like the y's. That'll probably be the easiest. So they're both positive. So I'm gonna go ahead and I'm gonna multiply this by -1. And now I'm gonna write it over here. So -y minus 4z is equal to -7. Now I can add these up. Those cross off. 7 minus 4 is 3z. And then we're going to subtract the 13 and the 7, and we get 6. Now we can solve for z. Z is equal to 2. Yay! Once we find one of the equations, now we can plug it back in, right? So, oops. There we go. So now let's find our y. I'm going to go ahead and plug it into equation number 4. So here's equation number 4. So this used to be y plus 4 times 2 is equal to 7. So y is, oops, not y is equal to, sorry. Y plus 8 is equal to 7. Subtract. Y is equal to -1. Once I find that, now I can find my x. It looks like my first equation will probably be my easier equation. So my x, so x minus 2 times -1 plus 3 times 2 is equal to 9. So x plus 2 plus 6 is equal to 9. So that'll be x plus 8 is equal to 9. So x is equal to the number 1. So we have our x, we have our y, we have our z. So here is our lovely answer. I'll put it up here. So A and S. So it's an ordered triple. So x comes first, then y, then z. So this is our answer. So that means this equation is going to work into the first, these numbers are going to work in the first, second, and third equation. Okay, so go ahead and pause the video and try example number 2 on your own. And when you are ready, I will also show you how to do that. So here we go. So again, I'm going to call this 1, 2, and 3. So again, figure out which variable you want to eliminate. This time the x's don't look like they're the best. I'd probably go with the y's or the z's. Again, it doesn't really matter. I'm going to go with the y's. So here we go. So this will be x plus y plus z is equal to 6. And then I'll take my second equation. And this will be 2x minus y plus z is equal to 3. I don't have to manipulate. This one's a little bit easier. So 2x plus x gives me 3x. Those cancel away. 2z equal to 9. Brand new equation. Never seen this before. So call that equation number 4. So for sure, I have to use equation number 3 because I have not used that one yet. So 3x plus y minus z is equal to 2. And again, I want to eliminate the same variable. So I want to eliminate the y. So it makes more sense to use the second equation. So 2x minus y plus z is equal to 3. Add this up. This will give you 5x. That cancels away. That cancels away is equal to 5. This will sometimes happen, right? You'll actually be able to solve for a variable right away. So x is equal to 1. So we actually didn't have a fifth equation on this problem. Okay. Once we find our x, let's plug it back into this equation. So 3 times 1 plus 2z is equal to 9. So 4 plus 2z is equal to 9. 2z is equal, oh, sorry, this is not 4. That's my fault. I added those instead of multiplying. Sorry, 3 plus 2z is equal to 9. So subtract 3 to both sides. I get 6. So z is equal to 3. So again, I got my x, I got my z. So now I just need to find my y. So for my y, again, it doesn't really matter. I'm probably going to stick to the first or third equation because it's a positive y. The first equation looks way easier. So I'm going to say 1 plus my y plus my z is equal to 6. Again, 4 plus y is equal to 6. That must mean y is equal to 2. Again, this is easy. As 1, 2, 3. Yay! All right. The next video will be 3 more examples, but I will show you about the inconsistent and many solution type of problems.